In July, a mountain shook 331 times. Most of those tremors were microscopic. They came and went in seconds. Too small to rattle a window, too shallow to reach a basement. And for 7 straight years, this exact kind of trembling has meant absolutely nothing. The scientists watching this volcano have logged thousands of similar signals since 2019, and every single one of them was eventually explained. Every one of them was eventually dismissed. But then, tucked inside those 331 earthquakes recorded just last month, there was one that was not like the others. One that did not belong to the same system. One that came from somewhere far deeper, in a place the other quakes never touch. And that single earthquake, barely strong enough to register on a seismograph, is the reason volcanologists are now watching this mountain. Every week. The mountain is Mount Pelée. And if that name means nothing to you right now, that is about to change. Mount Pelée rises at the northern tip of Martinique, a French Caribbean island sitting roughly 1,500 miles southeast of Florida. From a distance, it looks exactly like what you would expect from a tropical island paradise. Green slopes, cloud-wrapped summit, quiet forests running all the way up the flanks. There is nothing about its appearance today that suggests what it is capable of. But on the morning of May 8th, 1902, this mountain ended an entire city in under 2 minutes. Saint-Pierre sat about 7 kilometers downslope from Pelée's crater. It was the largest and wealthiest town in Martinique. It had a theater, a cathedral, electric tramways, and a reputation as the Paris of the Caribbean. At 7:52 in the morning, Mount Pelée unleashed a pyroclastic flow. A searing wall of superheated gas, ash, and volcanic debris raced down the slope at over 500 kilometers per hour. Within 2 minutes, Saint-Pierre was incinerated. Nearly 30,000 residents perished. Almost instantly, their lungs scorched by toxic gases, their bodies consumed by temperatures soaring above 1,800 degrees Fahrenheit. The cloud moved through the city the way a shock wave moves through water. It did not discriminate between buildings. It did not stop at doors or walls. If you were outdoors, you died. If you were indoors, you died. Upstairs, downstairs, it made no difference whatsoever. The only thing that saved anyone that morning was solid rock between their body and the mountain. 3 people survived. Lugger. Silbaris, a prisoner, was locked in a stone cell with almost no ventilation. A shoemaker named Léon Compère Léandre lived on the outskirts of the city, at the very edge of where the pyroclastic current reached. A young girl named Havivra da Ifrile reportedly escaped in a small boat to a sea cave before the eruption struck. That is the survival profile of a nuée ardente, a dungeon, the outer boundary, a sea cave, 3 people out of 30,000. This is not a volcano that gives warnings you can outrun. This is a volcano that erases the question entirely. And I want you to hold that fact in your mind as we go deeper into what the instruments are reading right now, because the past has a very specific and uncomfortable way of informing the present with Mount Pelée. Mount Pelée last erupted between 1929 and 1932, after that for decades it was quiet. Generations grew up on Martinique beneath this volcano without any serious alarm. But since April 2019, things have been shifting beneath the surface in ways the Observatory has been carefully documenting. Seismic activity began rising above its established baseline. Scientists observed numerous low-energy, shallow earthquakes, a few rare deep events, and the appearance of tremor and long-period seismic signals indicating movements of overpressured fluids in the volcano's hydrothermal system. Areas of degraded vegetation on the southwest flank appeared consistent with diffuse carbon dioxide degassing from the ground. For 7 years, all of that was monitored, cataloged, and ultimately placed in the category of background unrest. Elevated? Yes. Concerning enough to maintain a watchful eye? Absolutely. But not the kind of signal that forces a genuine escalation in the conversation about what this mountain might actually be building toward. That was the assessment for 7 years. And then July happened, and the numbers did something that the previous 7 years had not prepared anyone for. This is where the pattern changes. Between July 24th and July 31st alone, the Martinique Volcanological and Seismological Observatory confirmed 124 volcanic earthquakes in a single week. The week before that had recorded 45. That final week of July represented nearly triple the seismic activity of the week prior. And across the entire month, the observatory logged 331 volcanic earthquakes, averaging roughly 85 per week. When a volcano that has been producing a steady, low-level hum for years suddenly triples its output in 7 days, that is not background noise anymore. That is the instrument telling you something has changed. And the question that volcanologists immediately begin asking when they see a jump like that is not whether it is significant. The jump itself answers that. The real question is, what kind of earthquakes are these, and where exactly inside this mountain are they coming from? because the answer to that question is where this story stops being routine and starts being something worth watching very carefully indeed. Almost all of those 331 earthquakes had something in common. They were shallow, remarkably shallow. The vast majority of the seismic events recorded throughout July, including most of the 124 that struck in that final dramatic week, originated at depths of between half a mile and just over a mile beneath the summit. That is extraordinarily close to the surface for volcanic seismicity, and none of them exceeded magnitude 1. Not a single event was strong enough to be felt by anyone standing on the island. No rattling shelves, no swaying buildings, no felt shaking of any kind. To every resident of Martinique going about their daily lives in July, the ground beneath their feet was mechanism behind the shallow tremors, and it is a known, documented, monitored process at Pelée. The hydrothermal system has been the engine of the unrest for 7 years, so when the shallow earthquakes tripled in July, the scientific framework already existed to explain them. Pressurized fluid, fractured rock, a hydrothermal system doing what hydrothermal systems do, only louder this particular month. If the story ended there, the observatory would have noted the spike, filed their bulletin, and continued observing. But the story did not end there, because one earthquake did not fit. A single earthquake struck at roughly 3 miles below sea level, just west of the summit domes of Mount Pelée, 3 miles down. Every other earthquake in July was occurring between half a mile and just over a mile beneath the surface. This one came from 3 times that depth. And the location matters just as much as the depth, because 3 miles down is not the hydrothermal system. 3 miles down is the transition zone. It is the corridor that connects the superheated steam and pressurized fluid above to the magma reservoir that sits beneath. This is the region where hot gases and fluids can migrate between those two worlds, moving heat and pressure upward from the magma into the hydrothermal system above it. It is, in the most literal geological sense, the channel between what we can explain and what we genuinely do not yet fully understand about what is happening inside this mountain. And the fact that a seismic event occurred in that precise location, at that precise depth, and while everything else was happening less than a mile up, is the detail that changed the tone of the scientific conversation. A single deep event does not prove anything. Scientists are careful about that, and they should be. Volcanoes produce anomalous signals all the time that ultimately mean nothing. The history of volcanology is full of episodes where one unusual reading turned out to be a geological coincidence rather than a precursor, but context transforms the meaning of a data point. A single deep earthquake at a quiet volcano with no recent history of unrest would draw brief attention and then fade. A single deep earthquake at a volcano that has been producing elevated seismicity for 7 years, that just tripled its tremor output in a single week, and that is simultaneously showing physical deformation at the surface, sits in a completely different category. The context around this one event is what makes it the number you focus on, not the 331. That brings us to the second signal, independent of the seismicity entirely. Since May, scientists monitoring Mount Pelée have detected measurable ground movement around the summit. The land is rising. The deformation points to a pressurized source located roughly 0.6 miles beneath the summit, which appears to be causing the volcano to inflate from within. Something beneath the surface is expanding. It is pushing upward against the rock above it, and that rock is responding by physically lifting. The rate of movement has been close to half an inch per month, which sounds trivial until you understand what it represents. Half an inch per month of surface uplift at a volcano means something is accumulating pressure at depth with enough force to stretch and raise the ground above it. You're not measuring a geological twitch. You are measuring a balloon being inflated underground. And the source of that inflation sits in exactly the zone where the instruments are also recording elevated seismicity and where that one anomalous deep earthquake occurred. Now here is where the picture becomes genuinely complicated, and where honest scientific uncertainty enters the conversation. The rate of ground deformation has actually slowed slightly during the most recent 4-week observation period. The inflation appears to be easing, and when scientists see that in their monitoring data, they cautiously read it as a potentially positive sign. Pressure that is building more slowly is pressure that may be stabilizing, but they are also clear that several more weeks of data are needed before any confident conclusion can be drawn about whether the pressure beneath the volcano is genuinely subsiding, or whether this slowdown is simply a pause before the next phase of escalation. That uncertainty is not a failure of the science. It is the science being honest about what the data can and cannot yet tell us. So here is where things stand at this moment. 2 signals are running simultaneously beneath Mount Pelée, and they are pointing in opposite directions. Seismic activity tripled in the final week of July. Ground. Deformation is slowing. One signal says the system is accelerating. The other says it may be easing, and the scientists watching both of them are doing exactly what responsible volcanology demands in this situation. They are not drawing a conclusion yet. They are watching. They are collecting more data. They are waiting to see which signal proves to be telling the truth about what is actually happening inside this mountain. That tension, two instruments disagreeing about the direction of a dangerous volcano, is not a comfortable place to sit. But it is the honest picture of where Mount Pelée stands right now in the first days of August 2026, and it deserves to be understood clearly rather than simplified in either direction. What makes this tension particularly serious is the nature of what Mount Pelée produces when it erupts. This is not a volcano that gives you lava flows you can watch from a safe distance and photograph from a hillside. This is not the kind of eruption where you have hours to evacuate and roads to drive away on. The weapon of Mount Pelée is the pyroclastic flow, and specifically the variety that French volcanologists who witnessed the 1902 disaster named the nuée ardente, the glowing cloud. What collapsed from the growing lava dome on the morning of May 8, 1902, was not an upward explosion. The collapse sent a dense, superheated cloud sideways and downhill. It reached Saint-Pierre in well under a minute, traveling at hurricane speed at temperatures of several hundred degrees. The directional nature of that threat is critical. A pyroclastic flow does not radiate outward evenly in all directions. It follows topography. It channels down valleys and flanks. It moves with purpose and speed along the path of least resistance. And at Pelée, that path leads directly toward the populated northern coast of Martinique. Saint-Pierre was destroyed in approximately 3 minutes. The city that had taken centuries to build, that had an opera house, an international port, and a reputation as the cultural jewel of the Caribbean, ceased to exist in the time it takes to make a cup of coffee. That history is not being raised, here to manufacture fear. It is being raised because it is the factual baseline against which every monitoring reading at this volcano must be measured. When scientists say they need more weeks of data before they can assess the medium-term outlook, they are making that statement in full awareness of what the historical record shows this mountain is capable of. And the Martinique Volcanological and Seismological Observatory has been precise in its public language. The observatory stated that the probability of eruptive activity in the short term remains low. However, considering the observations accumulated over the past months and years, an evolution of the situation in the medium term, meaning weeks to months, cannot be excluded. That is careful institutional language, and it is worth parsing slowly. Low probability in the short term is not zero probability. Cannot be excluded in the medium term is not a prediction of eruption. It is an acknowledgement that the system is active enough and the signals unusual enough that the scenario of escalation has moved from theoretical to genuinely plausible. The alert level at Mount Pelée currently stands at yellow, which represents the second level on a 4-color scale. Yellow indicates elevated unrest, a state the volcano has maintained while the observatory continues to track seismicity, ground deformation, and gas emissions across the monitored network. There is no evacuation order. There is no imminent eruption warning. Officials have not issued any directive that changes daily life for residents of Martinique at this moment. But yellow is not the baseline. Yellow is not normal background. Yellow is the instrument telling you that the threshold between routine monitoring and active concern has already been crossed, and that the next set of readings will determine whether the situation holds at this level or begins moving in a more serious direction. There is also a broader hazard picture worth understanding here, because the threat from a major Pelée eruption would not be contained to the slopes of the volcano itself. Martinique sits along busy air corridors linking the Caribbean region to the United States. A significant eruption would inject volcanic ash into the upper atmosphere at altitudes used by commercial aircraft, potentially forcing the closure or rerouting of flight paths across a wide section of the eastern Caribbean. Ash clouds from volcanic eruptions are invisible on standard aircraft radar and are catastrophically dangerous to jet engines. The aviation disruption from even a moderate eruption at this location would be immediate, widespread, and economically significant across multiple countries. But that concern, real as it is, remains secondary to the immediate human geography of the situation. Northern Martinique sits within the potential impact zone of a pyroclastic event. That is the fact that the observatory is most focused on. That is the scenario that drives the weekly bulletins and the careful scientific language about medium-term evolution. What the data is collectively describing is a volcano that has been slowly waking up for 7 years, and that, in July 2026, produced its most concentrated burst of seismic activity in that entire period, including one earthquake from a depth and location that the previous 7 years had not generated. Whether that earthquake is the first data point in a new and more serious phase of unrest, or whether it turns out to be an isolated anomaly that the system quickly settles back from, is precisely what the next several weeks of monitoring are designed to determine. The instruments are running, the scientists are watching, and the answer is not yet written. This is the part that most people miss when they hear about volcanic unrest. The headlines focus on the dramatic numbers. 331 earthquakes, a volcano that killed 30,000 people, a mountain that is measurably swelling from within. Those numbers do their job. They create attention. But the real story at Mount Pelée right now is not the quantity of the signal. It is the quality of one specific signal inside it, and what that signal implies about the internal architecture of a system that has been building pressure for 7 consecutive years. The shallow earthquakes are the hydrothermal system speaking. The ground deformation is the pressurized source below the summit speaking. But that single deep earthquake, the one at 3 miles down in the corridor between the steam and the magma, is something potentially speaking from a different level of this volcano entirely. And when a volcano begins generating signals from multiple depths simultaneously, from the hydrothermal system above and the transitional zone below, the scientific community does not treat that as coincidence. It treats it as a system that may be more interconnected and more pressurized than previous monitoring periods suggested. The reason volcanologists pay such close attention to depth distribution in seismic swarms is precisely because depth tells you which part of the volcanic system is under stress. Shallow earthquakes near the summit typically reflect hydrothermal activity, which is energetic, and sometimes dramatic, but generally contained within a well-understood system. Deep earthquakes in the transitional zone between the hydrothermal layer and the magma reservoir reflect something potentially more fundamental. They suggest that the pressurization is not isolated to the upper system. They suggest that the connection between the deeper magmatic source and the surface expression of the volcano may be more active than it has been. Scientists have noted that since 2019, rare deep earthquakes have been detected at depths of approximately 10 to 20 kilometers beneath the volcanic edifice, indicating that activity has been occurring at multiple levels of the system throughout the current unrest period. The July, understanding what the ground deformation data is and is not telling us. Surface uplift at a volcano can result from several different sources. It can reflect the expansion of the hydrothermal system itself, as superheated fluids increase in volume and push outward against surrounding rock. It can reflect the injection of new magmatic material into a shallow reservoir. It can reflect the pressurization of gases migrating upward from depth. Distinguishing between these sources requires time, multiple instrument types, and careful pattern analysis. The observatory has attributed the observed deformation to a pressurized source at roughly 0.6 miles beneath the summit, consistent with inflation driven by the hydrothermal system or a very shallow magmatic source. The slowdown in deformation rate over the most recent 4-week period introduces genuine ambiguity. A decelerating inflation could mean the pressure source is losing energy. It could also mean the pressure has found a new pathway and is redistributing rather than building at the same point. Without additional weeks of data, the observatory cannot confidently distinguish between those two interpretations. That is the honest scientific position. And it is also why the next set of bulletins from the Martinique Observatory will be among the most closely watched volcanic monitoring reports in the Caribbean this year. What should the people of Martinique and the broader region take from all of this? The official position is clear and measured. There is no eruption warning. There is no evacuation order. The short-term probability of eruptive activity remains low according to the observatory's own published assessment. But the medium-term picture, the weeks to months horizon, carries an acknowledged uncertainty that was not part of the official language before this summer. That shift in language is meaningful. Observatories do not adjust their public communications without reason. When an institution that has been monitoring a volcano for years begins using phrases like cannot be excluded in the medium term, it is because the data has moved them to a position where the older, more reassuring language no longer accurately reflects what the instruments are showing. The language changed because the volcano changed. The 1902 disaster at Saint-Pierre is remembered not just for its death toll, but for what it revealed about the warning signs that came before it. The accounts of what happened in the weeks leading up to May 8th make it clear that warning signs were present and visible for weeks before the eruption. The lesson that volcanology drew from Saint-Pierre was not simply that pyroclastic flows are deadly. It was that monitoring, communication, and honest public information about volcanic risk are the only tools that create the distance between a population and a catastrophe. The Martinique Observatory exists because of 1902, the alert level system exists because of 1902, the weekly bulletins exist because of 1902. Every instrument on that mountain is a direct institutional response to the morning, when 30,000 people had no warning system sophisticated enough to tell them what was coming down, the slope toward them at hurricane speed. That context is why this story matters right now, even with no eruption imminent and no alarm issued. Mount Pelée is showing its most concentrated burst of seismic activity in 7 years of documented unrest. It produced one earthquake from a depth and location that the entire preceding period had not generated. Its summit is measurably elevated from where it was in May, and the scientists responsible for watching it are being precise and careful in their language precisely because they understand what this volcano has done before and what it is capable of doing again. The next few weeks of monitoring data will either show the system settling back toward its established baseline, or they will show continued escalation toward a threshold that demands a different kind of response. If that deep signal repeats, if the deformation rate reverses and begins climbing again, if the seismicity at multiple depths continues to increase simultaneously, the conversation about Mount Pelée will change very quickly. Until then, the instruments keep running, the scientists keep watching, and the mountain keeps its own counsel about what it is preparing to do next.